We're back and we're live. Welcome back, everybody. Welcome if you were new. I want to talk a little bit about what has been going down in the rest of the country. I live in California. We don't have much weather. No, we really don't. Even our snowstorms are really cute. We don't have much weather, but they've been having a buttload of weather in the U.S. Southeast, the Midwest, and the East. A lot of their weather actually originates in the northwest of the lower 48 states. So Washington, Oregon, and California. We get some weather that comes in from, say, Alaska or the North Pacific, and then it passes through our area. Maybe it rains, maybe it's just cloudy. But then by the time it gets to the Midwest heading east, by the time it arrives in the Midwest, it picks up some energy from the Gulf of Mexico, and they've been getting some. They're just hard to describe. Storm outbreaks, tornado outbreaks, heat waves, followed by tornado outbreaks. It's just been one goddamn thing after another. A lot of catastrophic flooding. So it rains 10, 12 inches in an afternoon or overnight. Northern Tennessee had a catastrophic flash flood that had houses underwater up to their roof eaves, so over the doors and windows up to the roof eaves, and they were showing pictures of a horse standing on the roof of a building. And unlikely that he jumped up there. He probably swam there, and maybe he climbed up on the roof from swimming, or maybe the water was above the roof and he just found himself standing in the water on a solid surface, and he didn't know what it was, and he was happy to be standing instead of swimming. And when the water finally receded, he was on a roof of a building, and that's just how that works out. Not a good place to be if you're a horse, so hopefully it worked out. But that's just a description of what's been going on over basically the eastern half, certainly the eastern third of the country, week after week after week of these colossal storms. Now, I watch the storms. I don't watch the weather forecasts. I'm not interested in the forecasts. The forecasts are necessary because you need to know when and where the storms are going to be. But I watch the live storm coverage, and I do this on YouTube. I watch people like Ryan Hall, Max Velocity, a couple of others, some storm chasers who are on the ground. Ryan Hall is in his house, but he's got all these storm chasers that work for him, and they're all feeding him all these video feeds, and he's looking at all these weather overlays and all these radar overlays, and he's processing things coming in on Twitter and live feeds from other places. And so he just acts like a central clearinghouse for live streaming of these ongoing storm events. So I find it interesting to tune into him when there's a big storm out. He does a really good job, by the way. Max Velocity does a pretty good job. These are the names of channels, by the way. Highly recommended. But the reason I watch them is because I'm a climate scientist and I'm interested in what's happening to the climate. We didn't talk about a lot in terms of climate talk. We tend to talk about, ice melt and sea ice loss and maybe droughts and maybe heat waves. And, we isolate these to different parts of the world. They're having flash floods in Qatar, and they're having, a heat wave in Pakistan, and then they're having torrential rains in, India or Italy or Texas. And, it's all broken up, and it's just all weather, and we look at the parts we're interested in. And sometimes someone will pop up out of their foxhole and say, oh, and there's an attribution to global heating or climate change and all this. So the weather reports and the pictures of the floods and the horses standing on the roof of the building, that's kind of interesting. But I'm more interested in what's actually happening when it's happening. I don't want to have it filtered through some clueless meteorologist who has 30 seconds to show you pictures of houses flooding and people kayaking around in the streets, right? And just say, yeah, whatever, that's drama. That's the Kardashian side of weather. Look at the flooding. Look at the horse sitting on the roof of the building. Look at the kittens, whatever. Yeah, it's just, okay, it's fine, but it's it's been stripped of all actual scientific data and all potentially scientific meaning. So I tend to go live. I tend to watch these live things. So we've been having a lot of really terrible weather, and I have spent literally uh, 8 hours at a time, actual 8 hours at a time, listening to and watching these things. I'm usually doing something else. Their weather gets started when it's still, early in the day here in California. So I'll be outside doing something, working with wood or pulling weeds or whatever, and I'll just be kind of listening, tuning in. And if there's something visually that's interesting or arresting, then I'll go to my cell phone and I'll watch for a little while. So I've been following this pretty closely, and most of what's been going on during this outbreak of severe weather, as they call it. Severe weather is a combination of lightning storms, um, usually called thunderstorms, but thunder is what you hear, lightning is what it is. So again, physics, people, lightning storms, hail, massive hailstorms, massive convection, surface level winds, and then of course tornadic winds, so tornadoes. Um, and there's always a question in terms of attribution: is all of this being made worse by global heating and climate change, or is all of this being made worse, or maybe better, by the ENSO, the El Nino Southern Oscillation, or the La Nina conditions, or whatever? And then, of course, we have the hurricane season coming up. That's a whole nother kettle of fish to keep an eye on. And my interest is what's happening. How bad is it? How long does it go on? Is it wrong? Right? Are people saying, "Wow, I've never seen anything like this"? That's data. When someone says, "I've never seen anything like this," that's data. When you see a oak tree that's probably 150 years old and has been through all kinds of weather and all kinds of storms, and all of a sudden, 6 of them in a row have been knocked down, or a bunch of them have been knocked down over a period of 6 months, and that tells you something about how often these things happen. When you have whole communities that have been there since 150 years ago. This community was built around the coal mining, and now they're flooded and completely destroyed, or two, and this happened more than once. Two tornadoes come through the same place, half an hour apart. One tornado knocks out the south side of town. The other tornado knocks out the north side of town. And these are 150-year-old communities that have been there since the Civil War and all this kind of stuff. And then you're thinking, okay, that's data. That's some data. They've never experienced flooding like this. They've never experienced tornadoes like this. They've never had 2 tornadoes in one day. They've never seen winds like this. These trees never got knocked down. These communities have been here for 150 years, and now all of a sudden things seem like they're changing. So that's when you got some data. Maybe things are a little different. Today, I'm not talking about all that, although all that leads up to what I'm talking about today. In fact, it's critical. A month and a half of severe weather, including a lot of rain, a lot of hail, which is just rain in solid form, has led up to what we saw last Thursday. I think it was Thursday, last week, in the city of Houston in the state of Texas. So I was watching this live. I had heard that there was possibly going to be some severe weather starting in East Texas around Houston. And so I was plowing through my news feeds on my phone, and I found a guy who was covering it live. And he was also using highway cameras. The Department of Transportation in really busy urban areas, they'll put up highway cameras to watch the freeways, looking for congestion, trying to figure out if they need to turn the metering lights on, or they're just monitoring traffic flow. So it's not real interesting. They're not monitoring homes and rivers and flood stages and all this stuff. They're monitoring traffic, but traffic can tell you a lot about what people are doing and what conditions are like in general, because you can see what's around. You see what's going on around the freeway as well as what's on the freeway, the actual lanes themselves. So this guy was trolling through freeway cameras, and he was not a weather guy, but he did have some radar up showing the cloud fronts that were coming through, and he was doing a pretty good job. I mean, he wasn't my normal go-to for live severe weather streaming, but he was doing a good job, and he was also looking. He was doing what I was doing. I was using him to do what I would have done myself. He was looking for signs of a disaster because he noticed in one of his radar images associated with Houston that looked like there was rotation starting in the clouds. The cloud was coming through, the wind stream was coming through as a line, as a front of wind, as what they call it, a bow echo. And it's just a long line of squalls, and it's just crossing the countryside. But this bow echo was crossing the countryside at about 100 miles an hour, which is really bad news. And so he was watching it, and he was, of course, watching it live, and he had all these cameras he was trolling through. And I'll get to the point here in a minute. And it was obvious. It was obvious there was something really, really bad happening, very bad happening, that was not forecast at all. No one caught this. I think they said something about there'll be some torrential rains. There could be localized flooding. There could be some high winds. So be careful. Don't be out on the streets if you don't have to be. And but bring in your lawn furniture. The usual stuff if it's going to be a windy day. But as this guy was watching this, he was like, "What is this? I don't understand this. They didn't predict this. What is going on here?" And I was watching it, and he brought up the radar at one point, and there was this gigantic rotating wind field. And he said, we may have a tornado in here. And I looked at the size of that wind field, and I reflected against the velocities of the wind coming in, which were hurricane force. And so now you got two things happening at the same time. You've got a outbound large radius wind field with high winds, 100 miles an hour. I think they even estimated some gusts were maybe even 150 mile an hour, well beyond hurricane force winds. And this guy was showing it didn't last very long, but it was there for a long. It's a gigantic rotating wind field. It was huge. Houston on the map is a big city, and this thing was as big as the city of Houston. And you could say, well, that's the wind field associated with some little tornado that's forming, but it didn't look that way to me. And combining that with 100 mile an hour winds in a rotating arc, what I copped to real fast was that this was a hurricane. It was a hurricane. Now, having hurricanes come ashore in Texas, in particular Houston, is really not that unusual. A few years back, they had a hurricane called Hurricane Harvey, that just about destroyed that region. It came in, it sat there for like 2 or 3 days. It came in from the sea, as hurricanes do, and it came in from the sea, and it crossed Galveston, and it went into the Houston metro area, and then it just kind of sat there, rotating and raining and rotating and raining, and pulling in moisture from the ocean and forming thunderclouds and raining all over Houston. They got like 51 inches of rain in like a 48-hour period. 51 inches of rain in a 48-hour period. They still talk about that. I don't think they've even fully recovered from it. 51 inches of rain. It was the most horrific thing any of those people had ever had to endure. 51 inches of rain. And where'd that come from? That was not predicted. Hurricanes are predicted. Harvey came in from the Caribbean Ocean where hurricanes form, and it came ashore. But I don't think anyone was thinking it was going to sit there for 2 or 3 days, acting like a conveyor belt and just sucking in moisture from the ocean and bringing it inland into Texas and dropping it that whole entire time it was sitting there. But that's what it did. So this was, I think it was during Harvey, it may have been a little bit before, but this was where I was first introduced to a phenomenon called a brown ocean event. It's basically you get conditions on land that to the atmospheric phenomena, to the Earth dynamic system, the land can look just like ocean. It's not a blue ocean because doesn't have the depth, right? It's a shallow sea. It's maybe even no more than a foot deep. So it's a brown ocean, not a blue ocean. It's a brown ocean. So you can have phenomena that happen on here that are called brown ocean events. And this is a real thing. It was somewhat theoretical, I think, up until just recently, but things have changed. You see, this is why we're paying attention to global heating. Things change, and they change in unpredictable ways. Now, brown ocean events were predicted as theory. You can have enough water, it could be hot enough, it could be persistent enough that actually to a hurricane, the land might look like a little bit like an ocean. It's not a blue ocean, it's a brown ocean. It's all theoretical, whatnot. I think it was Paul Beckwith who first introduced me to this idea. And as soon as he started talking about brown ocean events, it just clicked with me. It's like, oh yeah, of course. Of course. Of course, it's going to look like the ocean. The ocean got dumped on the land. Essentially, that's what these rainstorms do. The moisture is coming off of the warm uh, uh, Gulf of Mexico waters. It's transported inland a little ways, and it drops. It is ocean. It came from the ocean, and it's on land. But it's just all kind of mixed together now. It's not salt water, of course, because the salt stays back in the source ocean. But the fresh water that's evaporated out of the sea and goes inland 100 miles or 500 miles and drops. Well, it's just now it's all continuous. So they've been getting so much rain, as I mentioned, over the last month. I mean, like every week they've been getting catastrophic floods, catastrophic rains, and then they get heat waves in between. After it stops raining, then the heat comes in, and the Gulf of Mexico is not providing people with cool air. That's what the Pacific Ocean does for us. They are getting warm air. So if the sun is beating down and you're getting air in off the ocean, the air is already humid and hot from the hot water, and it's like being in a sauna, right? And everything just gets really hot. And then the storms come back in and they rain. And so you got this weird combination. And you have to start thinking about these things, how these things start to combine in weird, unexpected ways, except brown ocean events, though theoretical, are based on sound theory. And the theory is that when you get a lot of rain, the ground is saturated and there's standing water. It doesn't have to be deep. It just has to be enough that it can evaporate. Standing water that can evaporate, just like the ocean does back there in the Gulf of Mexico. The standing water that can evaporate, then that looks like the ocean surface to the Earth system. The Earth system. Now, I want to make a great distinction between some people thought that the Houston event was a tornado, and I believe it probably started that way. But people more recently who have been looking at the data, looking at the wind field, looking at the speed, looking at the rotation, they're looking at it and they're saying, well, that was either a big motherfucking tornado or that was a small hurricane. And so now they're having to hedge their bets a little bit. Was it, maybe it's something new. Maybe it's not quite a hurricane. Didn't last that long. And maybe it's not quite a tornado either. Maybe it was a tornado that turned into a small hurricane. Maybe it was never a tornado, not even from the beginning. Maybe a tornado spawned this new kind of thing. We just don't know. You can call it a torricane, right? Or a hurnado, maybe. It's something new. And here's what happened. Now, I'll go back to talking about the difference between tornadoes and hurricanes because it's actually really, really important. It's very important. But I'm going to just cut to the chase here. I'm going to say what happened in Houston is they had a hurricane. Conditions weren't perfect for hurricane genesis, and it didn't last very long, but doesn't matter. They had a hurricane, a huge wind field, hundreds of miles an hour or more wind speed. Tornadoes don't have that. And when you're in the tornado, yeah, it could be 200 miles an hour, but the wind fields are fairly small, unless it's an F5 tornado. And F5 tornadoes leave a huge signature. This just didn't have the huge signature of a tornado. This had the huge signature, the huge footprint of a hurricane. Hurricanes start at 50 miles across, and then they can get 1,000 miles across. But this had more of the feel, the wind velocity, the rotation pattern, the huge arc of wind coming ashore of a hurricane. And now they're saying Houston had a hurricane. But the problem with this hurricane, the reason why they're hesitating and kind of fidgeting a little bit about this, is that this hurricane didn't spawn in the ocean. They didn't track this to the Caribbean. This isn't Harvey. This isn't Katrina. This isn't any of those things. It didn't come in. It didn't hook into the Gulf of Mexico. It didn't hook into Louisiana, Texas, and Texarkana. It didn't do any of those things. They had no prediction of anything happening in Houston. Nothing. Wind, rain, maybe some wind. Be careful out there. Nobody was watching this thing. Out of nowhere, they spawned something weird north of Houston on land, not on dry land. And that's the key. So I'm going to talk a little bit about the difference between a tornado and a hurricane. And nothing could be more important than this. This is absolutely critical. Completely, absolutely bona fide, put on your thinking cap, critical. Difference between tornadoes and hurricanes. One difference is just how they act and how they look and how they behave. Like I said, hurricanes are huge. They're dozens of miles across, usually hundreds of miles across. Tornadoes are tiny. Even an F5 tornado might be 2 miles across. The biggest tornadoes ever seen that wipe out everything and tear the ground up and throw the dirt into the sky and just horrific events are a mile across, maybe two. The El Reno tornado is, what was that, 2.5 miles across at the most? So they're not that big. Hurricanes start at 100 miles across. So there's that. Also, and this is critical, tornadoes are formed. Tornadogenesis happens in the atmosphere, fairly high up, in cloud formations that are already rotating, called supercells. And the tornado formation and one supercell, a supercell can be 10 miles across, and it can spawn multiple funnel clouds. But it doesn't matter. The tornadoes originate, they are born, they are formed. Their initial genesis is in cloud formations that are rotating high up. And the tornado, as it spawns and grows, it descends to the ground as a funnel. It starts up here. You see it as a little funnel cloud way up in the clouds. You're looking up, you're doing this, you're looking up. Oh, look at that. Okay. And the funnel cloud, as it grows and becomes a real tornado, visually it descends until it touches the earth. And then they say, usually in excited tones, we have a tornado on the ground. We have a tornado on the ground. Well, that's exciting because it doesn't start on the ground. Tornadoes start up in the clouds and they descend. And so long as they stay in the clouds, I guess it's okay, right? But if they descend and they touch the ground, then you have a tornado on the ground. And they'll say, we have a ground verified tornado. We had a funnel cloud before. We had a scary looking cloud, an SLC. Now we have a ground verified tornado on the ground. All the energy for a tornado is contained in the atmosphere. And that's where it starts to spin. And when there's enough energy to spin it enough, then it descends. And now it's pulling winds in across the ground and it's sucking things up into the sky and all this debris and all this kind of stuff. Hurricanes are different. Hurricanes spawn over hot water. In this case, we talk about the oceans. The oceans are the only body of water big enough and hot enough to fit the definition of what a hurricane needs, which is hot water. Most hurricanes begin their life, cyclogenesis, off of the west coast of Africa, or maybe in the equatorial Atlantic. The prevailing winds steer them, and you can see them from space. They're starting to turn. They go through phases. They start out as a tropical depression, which is very slow, unorganized rotation until you get a tropical storm, which is a little more organized, but it's still not quite a hurricane. There's a wind speed threshold that it has to cross. And then your tropical storm, if it gets more organized and picks up more energy, it begins to spin faster, maybe gets a little more organized internally. Then you get a category 1 hurricane. And if conditions improve even more and there's even more energy in the water and there's even more energy created for the rotation, then you can get a category 2 up to a category 5. And these days they're talking about category 6 or even 7 hurricanes because the conditions now in the oceans are super conducive to providing super amounts of fuel to derive cyclogenesis or hurricane genesis. And that's because, unlike tornadoes, hurricanes form at the surface. A hurricane never has life up here in the atmosphere. It's always on the surface because it's getting its energy, not from high altitude cloud formations and rotation. The hurricane is getting its spin from the earth itself. The rotation of the earth gets the wind fields turning, and the energy for all that to spin up is found in the heat of the ocean itself. So if you're over cold water, you can't have cyclogenesis for a hurricane. If you're over land, you can't have cyclogenesis for a hurricane because they don't form over land and they don't form over cold water. The conditions are very specific. They have to be warm water. The water has to be warm enough past a certain threshold. And it's basically at 80 degrees Fahrenheit or something. And the other atmospheric conditions have to be correct not to disrupt the cyclogenesis. Wind shear can do it, dust can do it, some other things. So if conditions are good overall in the atmosphere above, and the water is warm enough and there's enough energy to use the Earth's rotation to spin these things up, then you get cyclogenesis, again, through a tropical depression, through a tropical storm, through a Category 1 hurricane up to Category 5, and maybe someday Category 6. But it's the ocean that determines this. It's the ocean. The heat content of the surface water of the ocean determines whether any of this happens at all. Other conditions allowing, it can happen if you have the right ocean conditions. So to summarize, tornadoes have their cyclogenesis from the clouds up here and way up, and you can see them as a funnel, and they descend to the ground until they touch the ground, and then you have a land-based tornado doing damage. Hurricanes take a long time, and a tornado can spin up in literally seconds. You can go from having a huge field of rotation that's 5-10 miles across to having a funnel cloud just showing, and then 30 seconds later you have a ground verified tornado tearing up the landscape. And it can go on like that for 15 minutes, 2 hours, and then it just dissipates. It goes back up into the clouds. Hurricanes can take weeks to form, and they can travel for weeks across the landscape, stealing heat from the oceans that they pass over to spin themselves up. And they'll spin up to a Category 3, and then they'll drop down to a Category 1, and then they'll spin back up to a Category 4. And they got mental problems, so they can't figure out what they're doing. So they go across the landscape. They'll pass, thousands of miles across the South Atlantic, hundreds of miles across the Caribbean Ocean, hundreds of miles through the Gulf of Mexico, and finally land ashore. And when they come ashore, then their life essentially is done, because now they're no longer over warm water. They're over dirt. Unless it's been raining on the dirt and there's water standing on the dirt. And it's hot water because it's not in the ocean. It can't really mix. Okay. It's just on the dirt. And there's been sunlight and there's fresh water on the dirt, and it gets hot and it stays hot. And when these hurricanes come ashore, because they only really see what's under them, they can be affected by high altitude events. But what they're really seeing, meaning what they're getting their energy from, is the surface underneath. And a hurricane can go from warm ocean conditions onto land and find warm water conditions, not ocean anymore because it's the land. So we have to use a different term. But what it looks like to the hurricane looks like a land ocean, a shallow sea. And, you can have shallow seas, right? Even swamps are kind of shallow seas. And so if there's enough water and it's hot enough and it reaches the threshold for what's necessary for a hurricane, for cyclogenesis and to maintain the rotation, then you can have a brown ocean event. And it was Paul Beckwith that first pointed that out. I don't know where he learned it. For all I know, he coined the term. He's pretty good about that. Brown ocean event, where these hurricanes come ashore and they just well, I guess I'm not ashore because it looks like ocean to me. So la-di-da, let's go party. And this is how you can have a hurricane come ashore and just not stop spinning. It continues to spin because it's stealing energy from the surface. It's not the surface of the ocean. It's the surface of the land. But the land has so much water on it, standing water. It doesn't have to be very thick. 3-4 inches is enough. It has enough standing water on it that's hard enough. They're just la-di-da. It just keeps right on going. A brown ocean event. Now, what happened in Houston, and this is where we have to back up a little bit and say, okay, well, that's all well and good. A hurricane coming ashore from the Gulf of Mexico, finding suitable conditions that look like hot water, like could be interpreted loosely as an ocean surface. It just keeps going and spinning, and it goes inland and it sweeps out to sea on the Atlantic. And that's that's theoretically possible. If there's been enough rain and it's gotten hot enough in between storms and this thing comes ashore at just the right time and la-di-da, and, carry the one and drop the two and solve for X. And okay, it could still think it's over the ocean. Well, watch what happened in Houston. People are now saying, maybe that was a tornado. But if you just sit back and squint, close one eye and look at it, differently from a different angle, it looks more like a hurricane. Yeah, they both rotate. Tornadoes rotate and hurricanes rotate. But squinting at this thing, it originated over after a month and a half of storms. It originated this huge circular field of wind originated over warm water, happened to be in the central of Texas, but doesn't matter. Warm water. It has a gigantic wind field, really high winds all the way out to the edge, 100-mile-an-hour winds. And it's got obvious rotation. Some people are saying, "Oh yeah, that's a tornado." Other people are saying, "Well, if you just kind of squint at it, looks like a fucking hurricane." Yeah, it actually looks more like a hurricane. But the only problem you're having is, well, it can't be a hurricane because it didn't come off the Gulf of Mexico. That's your argument. We're going to go with that. It's not a hurricane because it didn't sweep in off the Gulf of Mexico after traveling for 3 weeks across the Caribbean. That's all you got. So it can't possibly be a hurricane. Yes, it can, because it originated over a brown ocean. Oh, well, that's just theoretical. Apparently not. I mean, it's theoretical until it happens, right? That's like how everything is. Going to the moon, oh, that's theoretically possible. Land on the moon. Okay, well, now it's not theory anymore. Sending helicopters to Mars. Well, I guess in theory, you could put a helicopter on Mars. They've got a fucking helicopter on Mars, okay? No longer theoretical. It's a fact. It happened. Moving on. So these things are always theoretical until they happen. Not theory anymore. Houston had a brown ocean event. They had a hurricane. They had a flipping hurricane. Spawned out of nowhere. No, I didn't travel for weeks across the South Atlantic and all these dramatic pictures from space and the eye and the hurricane hunters flying in and rescuing, risking their lives and all this important science and the storm track and all the noodle models and the wind field and the eye of the hurricane and where's it going to come ashore and all this drama and all this science. And no, because we didn't get any of that, did we? We didn't get fuck all. They got nothing. They just got a fucking hurricane. They got formed in the suburbs of North Houston. There you go. Brown ocean event. Hurricane. They got a hurricane. And it came into Houston with 100 to 150-mile-an-hour winds, just like you do. Just like you do. They come into Houston with 100 to 150-mile-an-hour winds, knocks all the windows out of the skyscrapers, floods everything, blows the trees over, crushes all the houses. Trees, great big oak trees, 2-3 feet across, laying on top of cars. Oh, yeah, and then the transmission towers. The transmission towers, that's been all over the news. There's a whole area of transmission towers. You just see them just stacked one behind the other. It's like some cyclops went in there and just grabbed me, just twisted them up and just flattened them on the ground. Like I said in the description, like twisted up lawn furniture. Yeah, twisted those things and slammed them on the ground. And these things are 200 feet tall, 300 feet tall. I don't know how big they are. And they're carrying millions of volts from thousands of miles away. And they're bringing all this to Houston because it's a modern city, has all these power requirements. And this wind field, tornadoes don't even do that as a rule. They're just not big enough. A tornado might, it'll have really high winds, but it'll pass between two of these towers. And even if it hits one of them, it might not be much bigger than the tower itself. So these towers are kind of built for tornadoes and wind fields and this kind of stuff. But you bring a hurricane in there and 150-mile-an-hour winds, and it just takes these towers, it just lines them up and just knocks them down, flattens them. I couldn't even count how many there were. They just showed this, this zoomed in image of all these towers, and there's like 1, 2, 3, 4, 5, off into the distance. God only knows what happened in town with all the electricity disbursement going on in there. Massive problems. They can have, 3 or 4 kilovolt lines that pass, next to the freeways on their own big towers and Probably flattened a bunch of those too. They got a huge amount of work to do. I don't even know where you start with something like that. I guess you got to get in there with a bunch of cutting tools and cut out those stupid twisted up towers and haul those things away with fucking helicopters. Where do you even start? Hurricane. That hurricane. It formed on land. It formed in a matter of minutes, maybe seconds. It was a brown ocean event. They had a brown ocean hurricane, formed over land, processed itself over land, gained strength over land, hit Houston, and died. Hit Houston and died. I watched the whole thing live on TV, on YouTube. Craziest thing I've ever seen. Craziest thing I've ever seen. I saw a couple of radar images of this thing as it was forming, and it didn't last very long. I saw a couple of images of this thing, and I was like, oh shit. What is that? That was my thought. We were watching it on the TV here at the dinner table. We were streaming YouTube to the TV on the dinner table, and I remember pointing to it. What the hell is that? What is that? I don't know what that is. Well, I'm not the only one who doesn't know what that was. Some people are saying, oh, well, that's just a strange looking tornado. Oh, we get those all the time. Yeah. Yeah. That's what you're going to say. Fine. There are other people looking at this and saying, excuse me, but I don't think that was a tornado. Well, then what was it? Well, this is going to come as a shock. But that was a hurricane. Brown ocean event. Wow. The tie to global heating is this. So much rain. So much rain. For so long. It turned that corner of the country, the lower 48 of the United States, that corner of the country, the southeast of the country, became an inland sea. So saturated, so much water, nowhere for it to go, draining slowly away, heating in the sun. And when the conditions were right, and I don't know what generated this thing, but when the conditions were just right, and the cyclogenesis began, it looked down, and what it saw under it was a brown ocean. And it was hot. It was hotter than the oceans ever get, because the oceans have depth and they mix, and the winds blow and they mix the water column, and the heat goes down and the cool water comes up, and it looks the average of all this, but it's not as hot as it can get on land where none of that mixing happens. And so after 6 weeks of critical storms and inches of rain and flash flooding and up to the eaves with water and all that, and the sunny days that came after, when the conditions were just right for cyclogenesis, that rotating cloud, it looked down at the ground and said, you know what, folks? I don't feel like, and I'm not feeling tornado today. You know what I'm feeling today? This is going to blow your mind. What I'm feeling today is hurricane. That's what I got. I'm getting hurricane vibes from this situation. So let's just mix it up a little, shall we? I know we're over the suburbs of northern Houston, and I know it's freeways and suburbs and Walmarts and Home Depots, but let's just shake it up a little, shall we? If it looks like an ocean, quacks like an ocean, evaporates like an ocean, let's just do some hurricane shit today, shall we? That's what happened. That's what happened. I saw it. I watched the whole thing on TV live. So, oh, that's going to hurt. And it did. Fucked them up. Really did. And right now they're all busy, planning their recovery and how we're going to replace these towers and how we're going to get people back on electricity. And it's so hot. We need cooling centers, and people don't have electricity. They can't cook food. They can't live in their homes. They can't even pump the water out of their basements. What are we going to do? We got all these crises. We have to, juggle all these chainsaws. And so right now they're juggling chainsaws, and no one's really looking at what happened. Well, when they sit back someday, a month from now or 6 months from now, they look at it, they're going to say, that was interesting. What was that? What are you going to call that? A torricane? A hurnado? It's a brown ocean event. Now, as global heating continues, we have no right to predict what's going to happen to us. At no time did anybody expect there to be so much rain and so much heat and so much flooding that that part of the lower 48, there's about 10 states down there in the southeast, that 10 state area would start to act like an ocean. It could, a shallow sea. And no one thought about that. That's a thing. Well, yeah, theoretically, it's called a brown ocean because it's ocean conditions over land. So let's start talking about brown oceans now. What can you get over brown oceans? That's now a new field of study. That's a thing now. That wasn't a thing before, but because of global heating, now it's a thing. We had no right, and nobody bothered predicting that that could happen. We had no right to expect that, and nobody doing theoretical work said that was going to happen. They had this idea of what they called a brown ocean event. It was generally focused on hurricanes coming ashore, traditional hurricanes coming in off of the Caribbean islands, coming through the Gulf of Mexico, coming ashore and finding conditions that promote cyclogenesis and continued rotation, and heading off into the country, spinning like a madman, happy to be a hurricane. That would be a brown ocean event. Nobody had any business predicting that a hurricane could form in the suburbs of North Houston, given those same conditions. But that's almost surely what happened. Now, there will be boundary discussions. Was it really just a really big tornado, or was it a really small hurricane? Was it a new kind of thing, a tornado that becomes a hurricane? Was it a hurricane that had a tornadic element in the middle? Gray areas, right? Nature is never perfectly one way or the other. Yeah, hurricanes can come ashore and spawn tornadoes, right? So, when you get these rotating wind fields, all kinds of crazy things happen. So maybe there was a hurricane formed that had a tornado at the center. Maybe there was a tornado that formed, but since it formed over a brown ocean, it promoted cyclogenesis into a hurricane. Who knows? So they're going to argue about this, what happened in Houston in 2024. And of course, chances are they'll get another chance to watch this happen someplace else, maybe Houston, maybe somewhere further to the east. It's still flooded. They still having catastrophic floods. They're still having rain. They're having rain right now in Florida. And, and the heat wave shows up, the sun gets hot, heats all this standing water. And who knows, maybe we're going to have another torricane or another tornado or whatever we're going to call this thing. Huge wind fields that are created not from conditions in the sky, but created from conditions on the surface. You see, this is distinct. This is the difference. The tornado descends from the clouds, right? Like Jesus. Hurricanes ascend from the ocean. They pick up their energy and they start spinning on the surface and they ascend, okay, and become visible from space. Tornadoes are tiny. Hurricanes are huge. Tornadoes spin up quickly, travel across the land at speed, and then die. And the whole thing can happen in 15 minutes. Hurricanes, are huge. They travel slowly, 5, 10, 15 miles an hour across the landscape. They arrive and, they're enormous wind fields of hundreds of miles an hour at the edges in places. And then they come ashore and they die. They come ashore and they dissipate over land because the surface conditions are wrong for cyclogenesis for these hurricanes. The surface conditions on the land are wrong, unless you've had 6 weeks of rain and punctuated by heat waves. Then, then the surfaces of the earth looks pretty good. Now the land surface looks really good for a hurricane. Wow, this is tasty stuff. I think I'm going to do a hurricane today. Ha ha ha. Is the equivalent. There's another side of this, another theoretical thing that I've mentioned on this channel before, called hypercane. Hypercanes are another theoretical, and as happens with theory, it's only theoretical until it happens, right? The basis for a hypercane is that it's a normal hurricane, but it's huge. It's really huge. 1,000 miles to 3,000 miles across. They're enormous. And when and they're so big that they can travel across entire continents, get back onto water and spin up again, go to another continent, cross that one, get back onto water, spin up again. And so they're hypercanes. They just don't die. They can have lifespans for a week, 2 weeks, a month. Theoretically, anything's possible. You could have long-lived hypercanes that maybe are immortal for all practical purposes. They could come to dominate the weather. The hypercane could be so big that it actually creates the weather that allows it to propagate. So as we just saw with, or as we see with brown ocean events where hurricanes come ashore and they find conditions to just continue spinning, a hypercane would come ashore and create ahead of itself the very conditions that look like a brown ocean event. A hypercane would come ashore with so much violence and so much wind and so much rain, that's the key, that it could rain out ahead of itself onto dry land, create a shallow sea. We call that flooding, okay, whatever. But it will look to the hurricane like a shallow sea. Now we just dumped all that water, 50 or 100 inches of water in a day or 2 days. It just dumped all that water on land, but that doesn't matter. It's still water on land. And so the hypercane can actually create conditions for itself to just continue on across the landscape, not even noticing that it's over land because it's over a brown ocean, which doesn't look like land. So this brown ocean effect, this theoretical construct that maybe just wiped out Houston, essentially, just blew them up. This theoretical construct isn't theoretical. The brown ocean event is a thing. That's probably what happened with Hurricane Harvey. The last time was also in Houston. This time was also in Houston. What makes Houston vulnerable is it's a little ways inland and it's near the sea. So it's really easy to create a brown ocean in East Texas or Louisiana, okay, right? Oklahoma, that's close to the sea and is an extension of the sea. What happened in Houston that's unusual this time is that the hurricane didn't come in from the ocean like a hurricane normally does and discover a brown ocean that it could continue on to, like Harvey probably did. Instead, this was a hurricane or a torricane or a tornado that generated over land. And that's what's going to throw people into a tailspin for a while. Watch for another one of these to happen, probably in the next several weeks or a month, right? Conditions are ripe, as we've just seen. Conditions are there for these things to form over land, if that's what's happening. So it might happen again. And if it doesn't happen this year, it might happen some future year. As the planet continues to heat, there will be more evaporation from the waters. The waters will get hot. The oceans are getting hot right now. The oceans will continue to heat. They'll continue to evaporate a lot of moisture into the air. There'll be huge masses of warm, moist air off of the Gulf of Mexico. They will come ashore and they will rain in the southeast of the U.S., probably all the way up to Ohio, all right, Chicago. They're going to rain. They're going to turn the eastern half of the lower 48 states, the eastern half of the country, will turn into a brown ocean condition. What's going to happen with that? I don't know. Don't know. What if all that happens and there's all this rain and there's all this heat from the sun and the global heating and there's all this heat and the water gets deep and the water gets hot and then there's a big convective storm that comes through. And normally that convective storm would spawn a bunch of tornadoes. It would be an atmospheric phenomenon up here with the cloud rotation. The funnels would descend and they would find the surface and then they would tear things up. But what if there's a brown ocean? And the convective storms come through and the convection starts and the atmospheric conditions look at the situation. Well, I could generate a funnel cloud from up here, but look here, I've got pretty good conditions for a hurricane. Why don't we just do that? We could get hurricanes over land. That's not really land. It looks to the atmosphere like an ocean. There's a lot of water. You only need like 3 inches. And there's heat and there's hot air and everything's there. It's all there. And if you think that can't generate a hurricane, Well, think again, because it's just atmospheric physics, folks. It's just atmospheric physics. And if the conditions are right for a hurricane, well, gosh, you might get a hurricane. That's the situation we're in now with global heating. But they're talking about, oh, sea level rise, it'll take hundreds of years. Oh, the bleaching of the coral, it's so sad. Oh, the food chains are thinning out, and the poor seals and the elephants and whatever are going to die. And global heating, we'll have hot days, and heat indices will rise, and well, it'll be terrible. But air conditioning and whatnot will fix that. There's nothing going to save you from the things you can't predict. You think you got a handle on this shit? You think you do? You think you got a handle on this? You don't. You don't. We've been lying to ourselves. We thought we had a handle on this. We do not have a handle on this, folks. We do not. These systems are dominated by chaotic elements. You're going to find out. We're about to find out. They found out in Houston. Yeah, you're going to find the fuck out what's going on. And you think you got a handle on this, and the heat is going to do this, and the heat is going to do that, and the droughts and the floods and the rain and the ice melting and the glaciers and all. You think that's it? That's all it's going to happen? All the things you could think of, all the things you can imagine with your little monkey brain. That's what the system is going to be limited to. This entire Earth fucking system that you don't even understand the first thing about any more than a toddler understands a race car. That system that you're just groping around in and pushing buttons and pulling levers and snapping things off. And, that system that you're experimenting with, you think you understand the whole thing, and you just know it's going to be nothing but ice melt and sea level rise and droughts and, more hurricanes or fewer hurricanes or something else. That you got a handle on it. That's all you're going to get. Well, you just got a hurricane formation in the suburbs of North Houston. Where does that fit into your monkey brain? What little puzzle piece just fell into that little empty spot that you knew was there? You didn't know there was an empty spot in the puzzle. You thought you had the puzzle all made. Oh, you're a chimp. How do you know anything? You're a toddler pulling levers on a race car. You don't know the first thing about it. And there's all kinds of holes in this puzzle that you can't even see because you're too stupid. And, well, we just had a puzzle piece fall in place in the suburbs of North Houston. What are you going to make of that? What are the chimps going to make of that one? I don't know. We'll find out. They may make nothing of it. Well, that's what happened. That's what happened. Next up, the same thing is going to happen again because the conditions are there. The conditions are sitting there on the ground right now. As I remember that 4 days after the original event, right now, as I record this, the conditions are still there on the ground. You think it can't happen again? Really? You got to bet on that? Just watch. Just watch. It's going to happen again. If not this year, the next year, or the year after that, because conditions just keep getting worse for us and better for cyclogenesis. And maybe you'll have nothing but massive tornado outbreaks for a while, and then somewhere the Earth dynamic system is going to sneak in a hurricane. And you're going to say, well, that was either a really big tornado or that was a hurricane. Dare I say it? Yeah, that's right. Open your aperture a little bit. The key takeaway is we don't know what we're doing. We don't know what to expect. No one knew that was going to happen in North Houston. Yeah, random things happen all the time. Not like that, they don't. That was big. That twisted up the transmission towers. That knocked windows out of the sky risers. That tore up downtown Houston. And they had no idea that was coming. They had no idea that was possible. There it is. No longer theoretical. It happened. So what else is going to happen? We don't even know. We can start to guess. If we can get hurricanes forming over dry land, well, there's lots of places that are going to be flooded. Who knows what else we can get? There could be all kinds of weather phenomena that are out there in our future that we couldn't even guess at. There could be a couple of things. There could be hypercanes. Here's one type of hypercane that actually is probably in our future. This is probably going to be a real thing. Starts in the Caribbean, goes into the Gulf of Mexico, hooks up into the lower 48, Texas, Louisiana, Alabama, and creates conditions for itself, as I just described, ahead of itself to create a path of brown ocean. goes right through as a category 4 hurricane, goes right through the eastern half of the US. Wind field 800 miles across. Okay, can cover 2 states at a time. Goes right through the eastern half of the US. Goes out over the North Atlantic. Finds proper conditions over the Atlantic Ocean, spins up some more, heads for England, goes across England. It's still 500 miles across, goes through the UK, batters everything to pieces. Huge rainstorms, flooding, driving the car, floating the cars out to sea, crosses the English Channel, picks up a little more energy, goes into Europe, it hits Belgium, France, right down through France, right across the Italian peninsula, tearing everything to pieces. Still 800 miles across, goes into Mediterranean, finds some warm water, spins itself the fuck up. Hits the trade winds and starts heading west. It goes right across North Africa, tearing the fuck out of everything. It's half over the Mediterranean, half over land. It's still picking up moisture, still picking up fuel from the hot Mediterranean. Goes across Algeria, goes across Morocco, tearing the fuck out of everything. Finds itself in the water off of West Africa. That's where it was born. But now it's not a tiny little tropical depression trying to eke it out of it in existence. Now it's a 500-mile wide category 4 hurricane, and it's back. I'm back, boys. Let's do this again. And it just goes across the South Atlantic, goes across the Caribbean islands, tearing the fuck out of everything, finds itself in the Gulf of Mexico. I know what to do here. Spins itself back up. Now it's 1,000 miles across. It's a category 5, category 6 hurricane. Hits the same place it was in 2 weeks earlier. Tears the fuck out of those people. It's still flooded from the last time it came through there. It says, hey, brown ocean, I know what to do with this shit. It spins itself back up. Now it's 1,500 miles across. Goes across the eastern half of the U.S., tearing the shit out of everything. Hits Washington, D.C., tears that place to pieces. Hits the North Atlantic, spins back up again. Goes for the UK. Hits the Canary Island, destroys them completely. Kills everybody in the Canary Islands. Heads for Spain. Comes ashore in Spain and Portugal. Tears the fuck out of those people. It rains, 100 inches of rain. Comes down in 24, 48 hours. Just everything on the surface just gets washed into the sea. Everything, every animal, every house, every car, everything in Spain and Portugal gets washed out to sea. The only stuff that doesn't make it to the sea is because it's like Noah's Ark. It gets caught on a high place. It goes across Spain, finds itself in the Mediterranean Ocean. Oh, that's still really tasty hot here. Spins itself back up. Now it's a category 6 hurricane. And the wind field is 2,000 miles across. And it goes across Italy, tears the place to pieces, heads into Turkey, tears the place to pieces. Finally, finds some appropriately strong trade winds. This thing is huge. It's changing its own weather now, right? Find some trade winds that are still big enough to push this fucking thing around. And it hooks down through Turkey, comes across the Middle East, the Near East, tears the fuck out of everything. Syria, everybody gets washed out to sea. Every living thing gets washed out to sea. Right through the West Bank and Israel, everything gets washed out to sea. Comes across Egypt, 100 inches of rain. Everybody gets washed out to sea. Everything that floats, every animal, every car, every truck, every house, washed out to sea. Goes across North Africa. Dips into the Mediterranean, goes across the Sahara, 100 inches of rain in the Sahara Desert, hits Algiers, hits Libya, hits Morocco again, and finds itself in the West African Ocean. It says, well, 3 times the charm, right? Off we go. Hypercane. Oh, that's only theoretical. Conditions for a hypercane don't exist. Well, it's only theoretical until it happens. Could it happen? Absolutely. Will it happen? Absolutely, it will happen. Global heating, violence, hot water, hot atmosphere, rotation. The rotation itself is caused by the Earth. Hurricane rotation comes from the Earth's rotation. Can happen anywhere at all. The Earth is always rotating everywhere. The Earth's rotation spins up hurricanes. Will happen. This will happen. What the hell are you going to do then? And when does it stop? When does it stop? Now, every time it passes over warm water, it steals some of that heat. And 2 weeks later, it could come right back around and steal some heat again. Eventually, maybe it steals all the heat. Maybe it finds out that there's a path through the North Atlantic that just doesn't have enough warmth to keep it going. But if it's 2,000 miles across, maybe it doesn't need heat to get across the North Atlantic. Maybe it has enough momentum, enough inertia, enough rotational velocity that it just keeps spinning until it gets to someplace that's warm again. And remember, every time it passes over land, it's creating its own conditions. It's raining like a son of a bitch. There's 100 inches of rain coming down. And so when it comes back around 2 weeks later, it's still wet. It's still got feet of water. And it's been heated in the meantime by the sun and by the global heating and by the heat in the atmosphere. And it just finds a brown ocean. Basically, it's going around and around and around. It just finds nothing but hot water and brown oceans. And it's the atmospheric heat and the sun and everything else. And it just keeps going around and around. When does this thing die? Who says it does? Who says it has to? Well, that doesn't match up with theory. Yeah, well, start re-examining your theory. Earth system scientist here says, you got a way to go, my friend. You better start opening up your aperture, and you better start thinking about what's possible within the realm, the limits of physics. Because everything I just described is possible within the limits of physics. But this thing just keeps getting bigger. It just keeps recreating the conditions it needs to keep going. And the only thing that stops it from spinning, the only thing that saves us from a hypercane is that it basically exhausts all the heat on the planet in the paths that it's following. It sucks out all the heat. Yeah, that's what you've got. That's what's going to save us. It finally runs out of heat. What part of global heating sounds like running out of heat? What part of global heating means there's not enough heat to run these things, these heat engines, essentially forever? And what happens to the world when there's a hypercane that just doesn't know how to stop? Doesn't know how to stop. What happens? We're done. That's what happens. And all your concerns about melting all the ice and the coral reefs bleaching and the brown pelicans are starving and the food chain collapse in the ocean and the sixth mass extinction and all the things that you thought you understood what your challenges were just got washed out to sea on 100 inches of rain. Washed out to sea. You had no idea. I do. I know exactly what this system is capable of. And when I was watching the YouTube video live of what was happening in the suburbs of North Houston, I was thinking to myself, oh yeah, that's right. That's right. We could do that too. That's what we're thinking about. How would we do that also? How could we, let's see, carry the one, drop the divide by 4, solve for X. Yeah, the physics are all there. The Great Red Spot on Jupiter is a cyclone. The Great Red Spot on Jupiter, which you can see from Earth in a telescope, is a long-lived superstorm. It's been there, apparently, since humans had telescopes. Doesn't mean it's going to be there forever. Doesn't mean it was there all the time before. But it's there now. It's just a superstorm. It's like, it's 8 times bigger than Earth or something like that. But it doesn't matter. It's a big fucking storm on Jupiter. You think we can't have big fucking storms on Earth? Who says we didn't have them before? How do you know? You weren't there. Who's to say that the dinosaurs didn't have to deal with hypercanes? Who says they didn't? There were lots of animals that lived in the sea. You ever think about that? Or are they living in the sea? Good question. Why were there so many lizards and reptiles and gigantic, fish and all? Why did all that stuff just stay in the sea? Maybe that was the safest place to be. While the land was being torn to rat shit by hypercanes. Now, how do you think all these coal seams that we're still digging out of the ground got formed? They're all formed of trees. Does that mean that every single tree just fell over one day at the end of its life? It just fell over and became coal, just like one tree just fell over. And then the next day or a day later, or a month later, another tree fell over on top of it. And a month later, 2 little trees fell over on top of those 2. And they just kind of gradually accumulated and formed this big coal vein. Yeah, that's one way to do it. What if that's not the way it happened? What if the way our coal seams formed was this? Conditions were ripe for hypercanes, systems that are 3,000 miles across that could go over and around and around and around. And all the forests in the North American subcontinent back 160 million years ago, all the forests were knocked down all in one day or all in one month. And they all got knocked down, and 100 inches of rain or 200 inches of rain came down weeks on end and washed all those trees out to sea, or washed all those trees into the swamp, and all the trees fell down at once, and all the trees got washed away, and they all ended up in the same place. And there's a pile of trees 300 feet deep. It all came there on the same day or within a couple of days of each other. And it wasn't this gradual thing where one tree falls down, another tree falls on top of it a month later, and then 2 months later, another tree falls, and it kind of accumulates slowly, and gradualism, and nothing disastrous, just things happening, nature doing its thing. You don't know shit about it. You don't know that's what happened. You don't know anything about it. Why were the dinosaurs so big? Maybe that's so you could wade through the 100 inches of floodwater. I'm just guessing, but my guess is as good as anybody else's. The coal seams may have all formed in a month from a hypercane, knocking everything down, washing everything out to sea. Why not? Well, we're going to find out, aren't we? We're doing this experiment, and we're about to find out. What's the saying? Fuck around and find out. Yeah, we're about to find out. Watch for it. Be ready. Be ready for it. If we get a hypercane, if we get something that's long lasting and it just finds those right conditions and it starts making its own conditions, if it starts making its own internal seas and they get hot and it can pass over the land just like it's an ocean, if we start getting that, if that's what's going to happen this year, next year, 10 years from now, game over. It's just game over. You don't have to wait for the ice to melt. You don't have to wait for the gradual flooding that, it just, half a centimeter a year. It's just a gradual flooding you can basically walk away from and say, ha, 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 it is to laugh, right? Hypercane, 100 inches of rain every 2 weeks for months on end, washes you out to sea. Everything could wash everything out to sea. The entire eastern third of the United States of America could be washed out to sea. The entire UK could get hit with a hurricane that's bigger than the entire island chain. Get washed out to sea. All of it. Every living thing. Every human. Every single human could get washed out to sea. 100 inches of rain, 200 inches of rain, weeks on end, everybody gets washed out to sea. Wow. You better start thinking about that. That sounds like science fiction. That sounds like something theoretical. Yeah, well, it's only theoretical till it happens. We got big problems. We should have taken care of this a long time ago, but we didn't understand. We're just toddlers. We don't understand how any of this works. But we're learning, right? What did we learn from what happened in Houston last Thursday? Did we learn anything? My guess is we didn't. But if it happens 2, 3, 4 more times, then people will start to say, oh, yeah, right. Oh, that can happen. That's a thing. That's interesting. I wonder if that was caused by sunspots. I wonder if that was caused by El Nino. Maybe it'll go away. No, it's not going away. Probably not going away ever, forever. And all I can really do is just get worse. That's all I can really do. Is just get worse. We're learning slowly, but we're always going to be way behind.